everyone. So I have first period honors chemistry in front of me. Everyone say hi. All right, and we are going to be reviewing the homework from last night. I know a lot of you guys were anxious to figure out how to do this. So here we go. You're going to need a calculator in front of you. You're going to need your homework in front of you. So pause this if you need to go collect all of that stuff. All right, but we're ready to go. So we already have a hand in the air. What do you want? Oh, you want to hit the lights? Yep, go ahead and hit the lights. All right. All right, everyone. So the two on the left, just flip. All right, so dimensional analysis practice. Here we go. The first problem said convert 360 seconds to milliseconds. All right, the problem with this worksheet that a lot of students struggle with is that they don't know what the conversion factor is. The last worksheet that you guys were working on, which was the shapes, the conversion factors were given to you, right? And so it was really easy. By the way, if you still have that worksheet, you should turn it in. Not right now, but before we leave today, okay? Make sure I get that shapes worksheet, okay? All right, but we're going to start this game just like you learned with the shapes. You always start with whatever they gave you in the problem. So this particular problem started us with 360 seconds. So we're going to put that on the top of the very first spot that we're going to use. And make sure, guys, you're going to get, you know, kind of used to me yelling at you if you're not used to showing your work. And if you're not used to showing your units, I'll yell at you, okay? All right, so there is the first domino, if you will, that we laid down. So we started our game. Remember, the one rule in dimensional analysis is that you have to cross-cancel your units. And the problem here is that I'm not giving you any conversion factors. So you're going to have to build a conversion factor by yourself. So in other words, one of the things that my students have in front of them right now is a picture of this. It says the metric prefix scale. And this is supposed to be memorized, and I want you to have it in front of you while we work on this, okay? Because some of you guys don't quite have this memorized yet, but we will eventually be memorizing this, okay, this little picture. All right, so coming back over here. All right, the problem number one wants us to go from seconds to milliseconds. So if you think about your King Henry, I know you guys are obsessed over doing King Henry, died by drinking chocolate milk. So if you think about King Henry, what you are being asked to do in this problem is to go from seconds, which doesn't have a prefix on there, right? So if it doesn't have a prefix on there, that is starting you at the base. And they want you to go to ms, which means milliseconds, which is this guy right here. All right. So the question is whether or not you know what milli means. So when you go back to that picture here, milli on this picture says 10 to the negative 3. In other words, it's really small, right? The prefix milli means that it's really small. So what we have to worry then about is figuring out our own conversion factor using the metric system. So you know that you need to go from this base unit to milli, and we have to come up with our own conversion factor. So which one is larger? That's what I'm always going to obsessively say to you. Which one is larger? Seconds or milliseconds? Which one's larger? And there's a reason why I'm asking this. Which one's larger? The seconds is larger. And the reason why I'm always going to ask you that is because whenever you're making your own metric conversion, the larger unit, in this case it's seconds, the larger unit will always get the number 1. Can you just remember that? In other words, what I'm saying is that I'm going to put the number 1 with seconds because I know that there are going to be many milliseconds in 1 second. How do I know that? Well, I know that milli is really small, right? So if you go back to this and you're looking at this milliseconds right here, hold on, let me just do a quick picture. Hello, TA. What's that? An extra paper that we're working on? Oh, all the extra copies are in the folder file right there. It says chemistry extra copies. Okay. Anyway, if you look at the milli here, the power here says 10 to the negative 3. But I just got done telling you that the larger unit, 1 second, should have many milliseconds in it. Well, milli has a power of negative 3, but when you are being asked which one is larger and you put the number 1 here, I hope you understand that we're going to take that negative power and change it to be a positive power, because there should be many of those small little guys in 1 second. So we know that milli means 10 to the negative 3, but when we made this metric conversion, I switched it from a -3 to a +3 because there should be 1,000 milliseconds in a second. All right, so coming back again over here, this is 10 to the third, and look at that. Do you see the equal sign? Anytime you guys see an equal sign, that's called a conversion factor. So I just made my own conversion factor that we can now use in the problem. How do we use it correctly? Well, there's only one rule in dimensional analysis, and it's cross-canceling, right? Okay. So if you have seconds on the top, you have to have seconds on the bottom. Well, here is your domino. Here's your little game piece. You have to play it correctly. So I have to put seconds on the bottom. So I'm going to put 1 second on the bottom because my conversion factor has that written right there. Well, what is 1 second equal to? Well, it's equal to 10 to the third milliseconds. Yay, you set it up properly. And look, you cross-canceled your units. You had seconds, and you just cross-canceled. All right, well then, how do we put this on the calculator? All right, and I see a hand already. What's up? Her question was, do we have to keep it in exponent form? No. But I would advise you that once we start getting into like micro and nano and pico, are you really going to want to draw 9 zeros? No. So if you can get used to the habit of just putting it into a power of 10 now, it'll be a lot easier later on. So you don't have to put it in 10 to the third. You could have said, 1, 0, 0, 0. But man, what a pain. You're going to have to start counting zeros and stuff. Okay? All right, so grab your calculators. Type in the very first number that is up on the top, which was 360. Go ahead and type that in. There you go, 360. Okay, now the question is, what do? Do we have to multiply now, or do we have to divide now? Well, what do you guys think? You have a number that's on the numerator. You see that 10 to the third and it's on a numerator? What does your gut instinct tell you to do? Multiply. Good. And the rule is very simple. If it's on the top, a numerator, you multiply. If it's on the bottom and it's a denominator, you divide. It is that easy. Okay? All right, so 360 times, and if you want to punch in 1,000, you punch in 1,000. If you want to do 10 caret 3, you guys know what a caret button looks like? Have you ever seen this one? It's a little hat. I don't know what they call it in algebra. The exponent. Okay, the question was, why is this different than putting in an exponent, like using your E button? If you want to use your E button, you are allowed to, but you need to make sure that you know how to use it correctly. The E button stands for times 10 to a power. So if you wanted to punch in 360 E 3, that would give you the correct answer. Okay, now I want you to be aware though that when you start hitting divide, because we're going to eventually have these powers of 10 on the bottom. So how are you going to do it then? You can't really use the E button when you divide, right? So using the hat button is going to be a little bit more convenient. Okay. All right, everyone, and what did you get? And I can do this without a calculator, and I'll explain how I'm doing that in my head. You'll notice I don't have a calculator on my desk. All right, so what did you guys get? Check your answers with people around you. Yay. Okay, so it probably fit in your screen, and it probably looks like this, 360,000. Am I right? And it fits on your screen. All right, well, that's good. Eventually, we're going to get to problems that don't fit on your screen. Can you take this value and put it into scientific notation for me? Because counting zeros, right, Leah? My poor TA. Counting zeros is like the worst thing. It sucks. Okay, so can we put this into scientific notation? Are you ready? Your decimal's here, but you need to have it in between the 3 and the 6. So how many times did you move it? A lot. Nice one. You moved it 5 times. And then, guys, you're going to have to get used to this as well. I also want a unit and a box around your final answer. Okay, number, unit, box. Alright, so making your own conversions, right? Kind of tough, right? Alright, well, that's what we need to get you guys, like, better at doing. Okay? Alright, here we go. So, hold on, I'm going to take a TO just for a second. Hold on. Okay, I'm back. All right, let's go on to number 2. Okay, number 2, starting the game with whatever they start you with, 4,800 grams. Okay, is the very first domino that you laid down. Okay, in this problem, look at your sheet if you need to, but you are going from grams to kilograms. So I'm going to ask you the same question again, and you'll get used to this pattern. Which one is larger, kilograms or grams? Which one's larger? Kilograms. Kilograms is larger. So the larger unit is always going to get the number 1. 1 kilogram. And what are you trying to go from? Well, you're trying to go from grams to kilograms, right? So there should be many grams in a kilogram. Go ahead and look at your paper. What is the power of 10 for a kilo? 10 to the third. And notice that kilo has the power of 10, 10 to the third. But we understand that there should be many of the smaller grams in a big kilogram. So even though the prefix kilo has the power of 10, 10 to the third, who are we going to give that 10 to the third to? We're going to give it to the grams because there's many grams in 1 kilogram. So you've seen it both ways. You've seen it where we took the negative power of 10 and made it positive for the little guy. Now you see me taking the power of 10 from the big guy and giving it to the little guy. Okay, that's what we're doing here, is we're figuring out how to make these conversion factors. Alright, so this guy's going to get your positive power of 10 to the third, even though kilo is the prefix that had the 10 to the third, right? Alright, let's use it correctly. Follow your unit, dimensional analysis, cross-canceling. So down over here, we're going to put 10 to the third grams, because we have to follow our unit. And then up on the top, we're going to put 1 kilogram. And you'll notice that I am obeying the rules of dimensional analysis. I'm cross-canceling. All right, in the first example, you had a power of 10 that was on a numerator, and you multiplied, right? Well, this time, you need to divide. So start with the number 4,800. Type it in, 4800. And this time, you're going to divide by 10 to the third. All right, what'd you get? 4.8, right? Okay, 4.8, and then what is the unit on this guy? Kilograms. And what do? You put a box around your final answer. Okay. All right, and notice that I don't have a calculator, so I'll let you in on a little secret, okay? When I look at these numbers that we're playing with in this problem, I notice that this first number, I could, if I were to write it in scientific notation, it would be 4.8 times 10 to the third, right? And then I'm dividing by 10 to the third. Doesn't that kind of cancel? Yeah, scientific notation is more than just like a useful tool for me. It helps me actually do math in my head. All right, so let's keep going though. All right, so that was just a quick example. All right, let's do number 3. You ready? Number 3, starting the game. Always start it with whatever, always start it with whatever they gave you. So 5,600 dm. What do you think dm stands for? Decimeters. Good job. Decimeters. And we're going from decimeters to meters, right? All right, same question as always. Which one's bigger? Which one's bigger? Decimeters or meters? Look at your little sheet if you need to. Okay, which one's bigger? Decimeters or meters? Meters is bigger. The larger unit gets the number 1. So I'm going to say 1 meter is equal to, and then we got to figure out how many deci. Well, look at the prefix of deci. What power of 10 is deci? -1, right? So deci is 10 to the -1. All right, well, we understand that there should be many decimeters in 1 meter because the meter is bigger, right? Okay, so deci has a power of 10 to the -1st, but we're going to make it +1. All right, so this is 10 to the +1 decimeters, and you just made yourself a conversion factor. You just have to use it correctly. Follow your units. 10 to the 1st decimeters is equal to 1 meter. Okay, is this multiply or divide, everyone? It is. Good. It is divide. Grab your calculator. So 5,600 divided by 10 to the 1st or just divide by 10. And can you do this without a calculator now? Can you do it without a calculator? Because the first number is 5.6 times 10 to the third, and then you're dividing by 10, so it becomes 5.6 times 10 to the... It was to the third, and now it's 10 to the second. You're taking 1 away, right? So 5.6 times 10 to the second, and then put a unit on there. Remember, you cross-canceled your decimeters, and put a box around your final answer. How you doing? Is it starting to make sense? Better? A little better? All right. It gets a little tougher, though, a little bit later on. I'm going to skip a couple problems because I really want to show you a different one, okay? Okay, so now let's switch over to problem number 6. Could someone tell me what problem number 6 says? Right here, a little louder. 5 micrometers to kilometers. Did I hear that correct? Okay. So on problem number 6, I want you to notice something. You are starting with a unit that has a prefix on there, micro. And by the way, that's a symbol for micro. And then you're also going to another unit that has a prefix, and that one's kilo. So in other words, you're starting on a non-base unit, and then you're also going to another non-base unit. You guys are obsessed with King Henry, right? King Henry died by drinking chocolate milk. And then after milli, what's the next one on your sheet? It is micro, but then you have to skip 3 and then you finally get to micro. All right, so in this particular problem, you are starting here. I would like to propose a rule for whenever you have a prefix going to another prefix. Anytime you have that situation, it is the best technique ever is just to make a pit stop on your base. Always go to your base. So in other words, what I'm saying is anytime you make a metric conversion, your metric conversion should have a unit without a prefix on it. It should have a base unit in your conversion. I'm going to repeat that. Anytime you have a metric conversion, I should see a base unit without a prefix in it. It'll help you. And I'll try my best to explain why. All right, and then finally you're going to kilo at the very end. So this is kind of the roadmap that we're going to follow. We're going to go from micro to your base, and then from your base to kilo. Everyone understand the plan? How many steps is that? That's 2. Okay, so anytime you're going to have a prefix to another prefix, you will be doing 2 steps. Are you guys ready? Okay, so start the problem as usual. Start with what they gave you, 5 micrometers. All right, there's our first domino being laid down. Okay, so our plan is that we're going to go from micrometers to meters first. Which one's bigger, micrometers or meters? Meters is bigger, and the bigger unit always gets the number 1, right? So 1 meter should have many micrometers in it. All right, so check your paper if you want to, but this should eventually become memorized. What is the power of 10 for micro? It is -6. So, but we should understand that there are many micrometers in a meter, so we're going to change that -6 to +6. You got it. So this is going to be 10 to the +6. There is your first conversion factor. Now you need to lay that down correctly and make sure you're cross-canceling your units. So we need to make sure that we're cross-canceling micrometers. 10 to the 6 micrometers goes on the bottom, and 1 meter goes on top. Well, this step, what did it do? It successfully cross-canceled micrometers. But now you're stuck on meters. Okay, so this is going to take our second step. In the second step, look at the plan. You're going from your base unit, meters, to kilometers. And I'm going to ask you the same question I ask every time. Which one's bigger, kilometers or meters? Kilometers is bigger. Okay, so the number 1 is going to be with the kilometers, and we should understand that there should be many meters in a kilometer. How many? 10 to the third. Okay, so here I'm going to put a 10 to the third. And we just need to make sure that we follow the unit very carefully. So I'm going to put what down here? 10 to the third meters. And then 1 kilometer on top. So what am I doing here? Well, I'm cross-canceling those meters so that I'm left with kilometers on the top. Okay, so since you have 2 steps in this problem, both of those numbers are on a denominator. So I want you to listen very carefully to how you punch this in. Are you ready? Always start with what they give you. 5. Go ahead. 5. Got it. All right, the next number, 10 to the 6, is on a denominator. When you have a denominator, you divide. DD, denominator divide. That's how I remember it. Okay, so 5 divided by 10 caret 6. Go ahead and press equals. All right, now divide again. How many times did you just press divide? Twice. You hit divide twice. Go ahead and hit divide again. And 10 caret 3. And go ahead and press enter. And I can do this without a calculator. Can you? When you divide, don't you take the power of 10 and you subtract, 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 right? Okay, so anytime you divide a power of 10, you're subtracting. So watch this. I see a 6 right here and a 3 right there. 6 and 3 is 9. I know that this answer should be 5 times 10 to the negative 9. How did I do that? Yeah? You getting it? The scientific notation review packet that I gave you at the beginning of the year? That was for a reason. Okay, you can start doing this in your head if you want. All right, you ready? 5 times 10 to the negative 9 kilometers. Now, make sure you're getting this number on your calculator. If you're not, you're probably pressing a funky button, so stop it. If you want to, you can use parentheses. All right, do what you need to do, just as long as you're getting the right answer. And did everybody get that okay? Raise your hand if you got that on your calculator. You doing okay? Excellent, excellent, excellent. So how many of you guys would say that just from this particular lesson, you are feeling way more confident with your skills? Okay. How many people realize now that they need to memorize what I just wrote down and hand it out to you, that one PowerPoint slide? Do you need to memorize that? Yeah. How many people would say that making flashcards of these metric conversions with the power of 10 on the back would be a useful tool? You think? All right, good. Hey guys, let's build some skills right now and start practicing these problems together, because right now I'm signing off, and that was your lesson, okay? Of course, with you guys, I'll give you a little more, but I'm signing off from my headphones, okay? All right. All right, everyone. Signing off. Toodaloo.